Hi, I'm going to show you how to run the animated hypothesis test on Data Classroom, and specifically we're going to look at the chi-square goodness of fit. This animated test is going to take you through the math step by step, and it's different from our graph-driven hypothesis test, which you see in the graph maker, because that's just quick and gives you results. This is actually going to explain and do a little bit of teaching as we go. So first thing, we need to pick a data set that is appropriate for a chi-square. Of course, you can always upload your own. That's usually the coolest when students are working with their own data. But I'm going to select this, is this coin fair? And you can see in parentheses, it says chi-square, indicating that it's a good fit for this. So I click it, and we go into the data set. Now, this is the table view. And you can see the description of the data set up here. And I'm going to just expand this window by clicking that little arrow there. To just give you a summary of what this data set is all about, a teacher asked her students to conduct 100 coin flips. They recorded the data for each coin flip. Each coin flip, all 100 of them, gets its own row in the data set. That's tidy format, and that allows the computer to work with that data more easily. When at the conclusion, one of the students conclude that this coin is rigged, there's no way we could get that many heads by chance. But what do the data show? Was this coin rigged? So to do that, we're going to do the chi-square goodness of fit test, and to see if these results do in fact deviate significantly from the null hypothesis of a 50-50 distribution of heads and tails. So I'm going to contract that for a second. So now just to look at the data, you can see we have this first column over here, which is called coin flip number, and it's been typed as information. So again, right here, this is where you choose the type of a variable. This one has been set as info. This is just numbered 1 through 100. Which coin flip was it in the sequence of all 100 that they did? Over here, this is result, and this is a categorical variable, and the values for it are either head or tail. And if I scroll down, you can see there are 100 rows in the data set, like I said, and everything is either head or tail. Also note that by clicking this little DV, this is turned red, and we have indicated that this is the response variable that we are checking on with our chi-square test. This is the dependent variable we have chosen. So first step here, go up to prepare data set for animated hypothesis test, right here. Click that. You'll get this modal that will open up. And this is a checklist. You'll notice that everything is green here, meaning this is ready to go. This is going to help you determine whether a data set you're working with is actually a good fit for the chi-square goodness of fit, or the t-test. You can cancel choice here and pick t-test, and you can see then I get some cautions, things that we have to address, because this data set is never going to be a good fit for a t-test. So I'm going to go back to chi-square goodness of fit, and I'm going to click sample per row, because that's the format we're in. And now you see everything is ready. So you can just click OK and essentially just skip through this checklist with our pre-packaged examples. If you're uploading your own data set, you will have to work through this checklist. So I click OK. Now this Analyze Run a Statistical Test button becomes red. I am going to click it, and we're gonna get started here. It's warning me that I have not saved changes to my data set. If you want to preserve any changes that you made to your data set, this is the place to save them. So I'm just going to do that. Make sure I've saved my data set. I come back to Analyze. Okay, now analysis title. You can give it any title you want here. This is going to be the title that will be saved in your list of analyses, so you can access it later. So I'm going to say demonstration of chi-square goodness of fit. So that's going to be my file name. Now your research question, it's really important before a student engages in a hypothesis test that you want them to stop for a second and think about what is the question they're testing. And now you can see the computer is suggesting this, our counts as expected across all categories of result. And so I'm going to write that in here. You could actually just copy and paste it. I think I can't do that while I'm in the Screencastify here. So I'm going to type it out. Across all categories of results. And that was the name of my variable there. But you may also want students to add to that in their own words a little bit. So what you really want to know is, are the coin flip outcomes distributed, we'll say 50-50, right? And that's saying that is our null hypothesis here that we are testing. So I'm gonna go ahead and start analysis. I click the green button in the corner, and we get into the window to actually do the hypothesis test. I'm going to explain the real estate here. So what we've got is over here. This is going to be an animation that is showing how the equation works and how the quantities in the equation are derived from your data. So we've got this horizontal bar graph here. You can see number of samples that were tail, number of samples that were head. Over here in the upper right, this is are the counts as expected. And this is the dialog window. As you work through the math of this test, this is always going to be giving you suggestions of things to think about or small tasks that you need to do just to keep you engaged with the math. Down here in the bottom right, and I'm going to get rid of my head for a second, this is the lab notebook. This is going to keep a record of everything you do as you work through the chi-square test. And then at the end, you can export that. You can open it as a Word or a Google Doc. So that's something for you to take out of here. It can be the seed of the results section of the lab report. It can be part of a poster presentation. It can be an assignment all in itself. You can do whatever you want with that. Okay, so let's go to the dialogue. We're going to walk through this. Oh, I almost forgot. One more thing I want to point out. Up here on the white part of the screen is your research question. Are the counts as expected across all categories of result? Are the coin flip outcomes distributed 50-50? So that's pegged to the top. I can always see that. Okay, back to the dialog window here in the upper right. Are the counts as expected? Before we do any math, we want you to look at the graph and just think about, are the counts of samples as expected across all categories of results? And what we mean here are they as expected given the null expectation, the null hypothesis? And then I'm going to grab and use the slider here, and I'm just going to move it to where I think it belongs, okay? And so if our expectation is 50-50, and we have, I think it was 57 heads and 43 tails here, what do I think is happening? And maybe I want to move it, like, maybe I'm kind of skeptical. And I think that, maybe there's some indication that the counts might be different from expectations. So I dropped this P slider at 0.12. There is no right or wrong answer here. This is just, what do you think? Okay, and this is akin to simple estimation skills you would use for arithmetic. This is what we want kids to be building toward with statistics. When they look at visual representation of data, they should be able to make some estimates of statistical difference there. Okay, so now I click done, add notes, and you can see that now that got logged in the lab notebook. Here's my research question. Here's my choice of test. It's the chi-square. Here's my visual impression. And that's all getting recorded. Now we're ready to move on to the next. I click this purple next button right here. Okay, how would you expect the counts to look? This is what you're thinking about now. How many samples would you expect in each category? I'm going to click this expect even distribution, click it, and now you can see on the animation we get this line where it's showing me, okay, we expect 50 samples in each category. Here, we just got that. It was an even distribution, 100 samples, 2 categories, 50 samples in each. Okay, so now I click next, And now this is an opportunity to set your expectation at something other than 50-50. For this problem, the expectation is in fact 50-50, so we can skip this step. However, if you were doing some test where the null expectation was not 50-50, say, for example, you were doing some kind of Punnett square test and you expected the distribution to be maybe 3/4 one category, 1/4 the other category, this would be a chance where you can set your expected counts to whatever those are and sort of reset your null expectation. In this case, it is 50-50, so we can skip this step. I'm going to click the blue skip this step button. Okay, so now we have logged our expected counts. I'm going to go on to next. Now is the chance where we enter our degrees of freedom. This is not a full explanation of what degrees of freedom is, but if you want a little help, you can click on the question mark by any vocabulary, and it tells you that degrees of freedom for this test is number of possible result categories -1. We have 2 categories, head and tail. So 2 minus 1 is 1. So here's where I can change the degrees of freedom, and you'll get this will appear green and it will say that's right. You can also see that it draws the chi-square distribution of the test statistic over here on the left. When it does that, you will get this line that you can move. And what this does is it will just show you the area under the curve as a decimal, area to the left under the curve and area to the right under the curve. And so you can play around with this. And so if you have an alpha of 0.05, I moved this here where this is actually the critical value, just slightly less than 4. And actually, I know for a chi-square goodness of fit with 1 degree of freedom, the critical value is about 3.8. And you can see that is indeed where 95% of the area under the curve is to the left of this value, 5% is to the right. So ultimately, this is what we're looking for. If our chi-square test statistic is greater than 3.8, it's over here to the right, well, then that's going to be a significant result, indicating that these do, in fact, deviate from 50-50. If it's somewhere over here to the left, that's going to indicate that it does not deviate significantly from 50-50. In addition to being able to play with this slider and put it anywhere you want, you can also play with the degrees of freedom. And you can see as I start cranking those up, 3 degrees of freedom, 4 degrees of freedom, 5 degrees of freedom, 6 degrees of freedom, 7 degrees of freedom. You can play with that. But you see how the shape of this distribution changes. And the effect that has is the more categories you have, the more degrees of freedom you have. And the more degrees of freedom you have, the higher value of a chi-square test statistic you need to reject the null hypothesis. And that is simply because the more categories of your variable that you have, the more opportunities you have to deviate from that null expectation, the more opportunities you have for randomness. So that threshold to show statistical significance just becomes higher. That's a little bit different from other statistical tests. Most statistical tests, you think about more degrees of freedom you have, then it makes it easier to reject your null hypothesis. But in the chi-square test, the degrees of freedom are determined by categories, not by individual samples. So this is a little bit different. Okay, so I'm going to turn my degrees of freedom back down to 1. That is, in fact, the correct degrees of freedom for this test. And then I'm going to click Done, Add Notes right here, the yellow button, and it gets logged. And then I'm going to click Next to move on. Okay, so from here, we're going to calculate the chi-square. Now, if you hover on the vocabulary term, you can see the equation. And it's this, you do this observed minus expected squared over expected, and you sum this value for each of the categories. So let's start calculating that. So calculate the difference. I click that, and it's just going to go through step by step. It's going to point out the expected value is 50. The observed is 57. The difference is 7. I click next. And I'm going to calculate the contribution. And so you can see over here showing you 0.980, and that was 7 squared divided by 50 equals 0.98. So now we're going to go and calculate that for all the remaining categories. In this one, we only have one more. So calculate the remaining. I click that, shows us, again, 0.98 for this. When you have only 1 degree of freedom, the value of each contribution is going to be the same for each. When you have many categories, they'll start to be different. So I'm going to go ahead and click next. And now we're going to actually sum those up. You can see the animation is starting to show, and it's reset this chi-squared value back down to 0. But as I add the values, so I click this red button, you can see it's summing those up. And the sum here is 1.960. So this is our chi-square test statistic, and it has moved the slider over here to the value of our test statistic, and it's showing us that 0.16 of the area is over here to the right of our test statistic. Okay, so this is greater than 0.05, which is usually the cutoff for statistical significance. So I click next here, and now it's saying, okay, well, your p-value for this test is 0.16. And this is the likelihood that the deviations from your expected values are the result of random chance. This does not meet our cutoff for statistical significance. So a p-value of 0.16 is usually interpreted as, maybe some indication that the counts might be different from expectations, but this does not allow us to reject the null hypothesis. So I'm going to move on to the next, and now I have a chance to write a conclusion here. And you can write as much or as little into this field as you want, this field right here. So are the counts as expected? I'm going to say something like the counts of heads and tails do not deviate significantly from the null hypothesis of a 50-50 distribution. We have no evidence, and this is how you would evaluate this from a scientific perspective. We have no evidence that the coin was rigged, right? Was rigged, and you could say something like, we conclude that getting 57 heads was most likely the result of random chance, right? Okay, so this is a conclusion you could write. There are many different levels to the complexity you can include when writing this conclusion. That's going to depend on what you and your students are hoping to do with this activity. I'm just writing that in there to show you how one might do it. So I click done, add notes. You can see this notebook is building up. That conclusion is logged. And now you get the chance here you can publish your notes as a PDF file if you want. So I'm just going to click that for a second, and you can see it produces that PDF file. The wheels are spinning doing that. If you had assigned this data set as an assignment in Google Classroom, that means that it had appeared in your news feed, students clicked on it there to get to it, then this would turn in this analysis into your folder for that assignment on Google Classroom automatically. So that's one way to do that for you Google Classroom users out there. I'm gonna make my face disappear for a second. This notebook, this is a record of everything we did. If I click this download as a Word document, it's gonna download the file. And when I download that, I can open that up as a Google Doc, or I can open that up as a Word doc. I'm just going to show you, what that file looks like. This is the lab notebook that we just produced. It's got your username, which is frequently your email, pegged to the top. You can see the date, the research question, the choice of tests, the visual impression, expected counts, all of the equations that were used, what your p-value was, showing you, where your test statistic fell on your distribution, your conclusion, and then a plot of the data. This is fully editable. You can resize images. You can add to the text. You can take away text. Lots of teachers like to use this as the results section for a lab report, and then teachers can start writing the lab report or around that, or students can start writing around that. So what you do with that is up to you. But that's it. That's how you walk through the animated hypothesis tests on Data Classroom. If I'm gonna go ahead and shut this window with the X and X out of it, and that will take you to the analysis. You can normally get to this through that browse tab, but you can see this is the demonstration of chi-square goodness of fit. It's owned by me. You'll see your own owner name there when you do this. If it's shared with a class, you can see that class represented there. You can see, when it was logged in. If they made a PDF of it, you can click on that icon to get it. You can also just open it up and go into it and take a look at it. And all of the work of your students will be visible to you in that format. So you will see your own work as well as student work appear in this list, but students will not be able to see each other's work. So that's it. That's how you run the animated chi-square test. If you have any other questions, feel free to email me at aaron@dataclassroom.com. Again, that's AARON @dataclassroom.com. And happy mathing and happy sciencing out there. And with that, I'm going to end this. Later.